want to design a Mealy machine for input that are nothing but the integer strings represented as a binary equivalent to the given decimals, and it will give output as a 0 when the number is represented as a multiple of 3. Otherwise, it will generate output 1 if the number is not multiple of 3. Okay, so for that purpose, what I did here is I have represented here decimal numbers and binary numbers. So decimal number 0 is divisible by 3. So modulo will be 0. Decimal number 1 not divisible. So 1, 2 not divisible. So 1, 3 is divisible. So 0. In this way, this table has been constructed here. And since we are dealing with the binary representation of it, I have taken here binary number equivalent to the given decimal numbers, right? What we are going to check here is this binary. Okay. Amongst this binary, whenever we have output as a 0, that would be represented as a multiple of 3. So let's move around. Q0. Initially, we'll say that output generated is nothing dash, because otherwise it will generate output even when no input is applied to it. So Q0 dash. Q0 will not generate any output. If we get 0, we are talking about any trailing zeros here. If 0 is the input, since we are going for Mealy machine, output is associated with the state. If it is 0, we'll say Q1 and the output generated is 0 because 0 is divisible by 3. If the output is 1, it is not divisible by 3. So let's say Q2 represents that, will generate output as a 1. That 1 is not divisible by 3. Next, what? If we get 0 here further, what will happen? We get 0, again it is divisible by this, right? If we get 1 here, what does it mean? Generate 1. We get further 1, that is 1 followed by 1. What to do? Let's look here. We talked about this 0 followed by any number of zeros, output is 0. If we get 1, then output generated should be 1. If we get any number of zeros followed by 1, again output generated is 1. If we get 0, 0, 1, 0, that means 0, 0, 1 and followed by 0, output generated should be 1, right? So 0, 0, 1, and we must go to a place where the output generated would be 1, but it will not be the same state. So let's construct one more here for 0. Q3, where the output generated is 1. Now this Q3 will represent the case when we have 1 followed by 1. Sorry, 1 followed by 0. Output generated 1, or 0 followed by 1 followed by 0, and so on. Next, 0 and 1 we have shown here for Q1. Okay, let's go for this Q2. Q2, 0 we have shown. 0 indicates that 1 followed by 0, right? 1 followed by 0. If we get 1 here in Q2, what it will signify? It will signify 1 followed by 1. Okay, 1 followed by 1 means what? Again, it could be this 1 followed by 1, wherein output generated should be 0. It could be 0 followed by 0 followed by 1 followed by 1. Again, output equals to 0. So when we are getting double 1 here, since before this we don't have anything, so it simply means 0 followed by 0 and 1, 1 1 or 1 followed by 1. Ultimately 0 0 1 1 output generated should be 0. So we can very well show this to this place when an output generating is 0. So what we got here, 1 followed by 1 output generated is 0, or 0 followed by 0 followed by 1 followed by 1 output generated is 0. Now what next? 0 1 0 0. So we have 0 1. Here this is our 0 0 1 0 followed by this 0. If we get 0, output generated should be 1. So we're talking about 0 1 0 and thereafter with a 0. With generalization we can say output generated is 1. Is this clear? 0 0 1 1. Now in Q3, if we get 1, what we should get? It would be nothing but 0 1 0 followed by 1. Where it is? 0 1 0 followed by 1. Output generated should be 1. Okay. So 0 1 0, and then if we get 1, what we need to do? Have clean closure. Output generated is 1. So this is a Moore machine for accepting binary numbers equivalent to the decimal number which are multiples of 3. Let's check for all these cases whether they match or not. 0 1 1 0 0 1 1 0, output is 0. 0 1 1 1, let's check output 1 or 0 1 1 1, output is 1. 1 0 0 0, output must be 1. So 1 0 0 0, output is 1. Let's go for this. 1 0 0 1, 1 0 0 1, output generated is 0. 1 0 1 0, 1 0 1 0, output generated is 1 0 1 1. Output generated should be 1. So 1 0 1 1, output generated is 1 1 0 0 1 1 0 0, output generated is 0. 1 1 0 1 1 1 0 1, output generated is 1. 1 1 1 0 1 1 1 0, output generated is 1. Last but not least, let's check for 15. 1 1 1 1. So 1 1 1 and 1, output generated is 0. So we have taken some sample case, and for all those sample cases, our constructed Mealy machine generates the required output. So this is your Mealy machine equivalent to the given description. Understood? Do you have any query on this? Anavi, do you have any query?
No, sir.
Okay, fine. Let's go for the next case now. Give Mealy machine for input alphabet 0, 1. If input ends in 101, output should be X. If input ends in 110, output should be Y. Otherwise, the machine should generate output as a Z. So basically, we have given two cases wherein output should be generated as either X or Y. So what we will do, we'll construct Mealy machine for these two cases only first. And in all the other cases, we'll say that the output generated is Z. Okay. So let's go for it. Starting with Q0 as usual. First is 101. So let's talk about this. Leave what output is getting generated in other cases. We'll simply go for 101 first. 1, 0, 1. In case of 101, output generated should be X. Q2, Q3. Similarly, for 110, we'll go for. So 1 would be this one to be traced, followed by, instead of 0, if we get 1, that case we need to check for. So 1, 1 followed by 0, Q4. If we get 0, then output generated should be 110, output generated should be Y. Okay, so these are the valid cases. Now we'll go for other cases for what? Now here, this doesn't satisfy the criteria of either X or Y, so we'll mark it as Z. Similarly for this, Z, Z. These two cases only will return output as a X and X. So in Q0, we have looked for 1 as a first input. What if we get 0 as a first input? Now what does mean 0? 0, if we have it neither matching with this 101 criteria or 110 criteria. So with generalizations, we can simply put it like this. We can simply say it that if we get 0, generate output as a Z, and still continue looking for 1 followed by 0 or 1 followed by 0 followed by 1. So this is the case for Q0. Now in Q2, we have shown for, in Q1, we have shown for 0 and 1 both. Let's go for Q2. Q2, we have shown for 1. What if we get 0 here? If we get 0, it means we have a sequence of 1 followed by 0 followed by 0. Right? It doesn't match us with either of the cases which we are looking for. That is 101 for X and 110 for Y. So if we get 0 in Q2, it signifies 100. We must go to the place again wherein we are looking for 101 or 110. That is nothing but state Q0. So if we get 0, simply have transition to Q0 with 0-Z. In Q3, what does Q3 signifies? Q3 signifies that we have already encountered 101 and we have generated X. So hereafter, we'll again look for 101 or 110. If we get 1, it means we need to look for either of both cases wherein X or Y output to be generated, and that case is nothing but Q1 after coming the input 1. So let's show this like this. 1 Z. If we get 0 here, same is the case. What? That 0 is nothing but the 0 after 101. We should again look for thing which we did in Q2. 0/Z. Okay. This is for Q3. Let's go for Q4. Now, what does Q4 signifies? Q4 signifies that we are looking for 110, wherein we have already checked for or scanned for 1 followed by 1. In Q4, if we get 0, we are generating output as a Y. But if we get 1, that 1 is nothing but this case. 1 followed by 1 followed by another 1. Right? Now this one would be the one from this case or this case, right? It would be either this one or this one. How to handle it? Any guesses?
Sir, self loop.
Yes. If we get one here, what we should do? We may continue with 1 followed by 1 followed by 1, 1, 1 and 0, right? It will still signify this 1, 1, 1, 0, right? One may consider that this one would be this, but before we go for checking 1 followed by 0 followed by this, it would have satisfied this criteria already, right? It will get consumed for 1, 1, 0. We should have clean closure on Q4 with 1/Z. This is for Q4. Now in Q5, if we get 1, we already checked for 1, 1, 0. So if we get 1, simply need to move to this 1/0 Z. If we get 0, we should simply go to here on 0/Z. This is a Mealy machine for input from alphabet 0, 1. If input ends in the 101, it will generate X. If input end in 110, it will generate output Y. And if it otherwise, it will go for generating Zs. So construction is complete. Any queries on this?
No, sir.
Next example. Give Mealy machine to convert each occurrence of a substring ABB by ABA. So we need to substitute in the place of ABB, we need to generate ABA. What does it mean? If we are getting B after A followed by B, after A followed by B, that B should be converted to A. That's all. And it's a Mealy machine. So let's go for it. Q0, first A, keep that A as it is. Then Q1. Here if we get B, keep that B as it is. Next, if it is B, that B should be converted to A. Okay. Now this is necessary. We'll go for the other cases. What does it mean? Other cases means what if on Q0 we get either A or B? For A we have shown if we get B here in Q0, we'll still look for A followed by B followed by B. So B generate B. In Q1 we already checked for B. So if we get A, still that A would be the first A from this ABB sequence. We need to continue with the same check. Here, instead of B, if we get A, it means we have A, B, and A, which is of no use to us because we are looking for ABB. So if this A is there, this A may be the part of next ABB. Right? So we should go to the place wherein we are coming from initial state on the occurrence of B, on the occurrence of A. So AB, if we get A, move to this Q1. Here in Q3, we are coming after converting this B into A. So from here again, we should look for on an input of A, look for ABB. On the input of B, we should again restart the search for A followed by B followed by B. So if we get A here in Q3, that A may be part of next ABB. So A/A. If we get B here, we need to go to the place wherein we are starting with our search for ABB. So this is a Mealy machine for converting each occurrence of substring ABB to ABA. Next, give Moore machine to change each occurrence of substring 120 to 121 over an alphabet 012. Here in the place of two input symbols, we need to check for three input symbols. And the case is very simple, that if we are getting 1 followed by 2 followed by 0, this 0 we need to convert to 1. So this 1, 2 will remain as it is. Only we need to check for this third symbol. Okay, other things will remain same. So let's do the thing for that only. Q0, since it's a Moore machine, output would be associated with state. We'll say dash to this. If we get 1, keep that one as it is. We're looking for Moore machine. So 1, go to Q1 wherein output generated is 1. If we get 2 here, if we get 2 here, go to a state wherein we'll generate 2 only. Let's say Q2 generating 2. Next, if we get 1, sorry, if we get 0, that 0 should be converted to 1. So 0, we must convert this to 1. Q3 generating output 1. Okay. So 1 to 0, if we are getting as input, we are converting it to 1 to 1. Now base criteria was satisfied. Let's go for other inputs. If in Q0, instead of getting 1, we get either 0 or 2, what should be done? We are just looking for 1 to 0. So if we get 0, we should go to a place wherein we are generating output as a 0. Q3, let's say Q4 generating output 0. Similarly, if we get 2 as an input, we should go to a state which is generating output as a 2. We are not disturbing our this cycle wherein we are converting 1 to 0 into 1 to 1. Okay. So this is for Q0. If we get in Q1, if we get 0, what to do? If we get 1, what to do? That we need to check. We have already shown for input 2 because the sequence required was this. So if we get 0 in Q1, what should be done? Go to the state wherein we are generating output 0. If we get 1 here in Q1, then that one may be this first one from the series of 1 to 0. So let's go for this 1. 1 followed by 2 followed by 0. We'll continue with our search. So 0 and 1, we have shown transitions. Here in Q2, in the place of getting 0, if we get 1 or 2, what should be done? That's the case. Here, if we get 1, it means that 1 may be again part of 1 to 0. So go back to the place wherein we are looking for 1 to 0. 1. If we get 2 here, we need to research for our 1 to 0 again, right? For that 2. So where we are doing that process. That process we are doing in Q0. But if we see here, output generated should be what? We have talked about 0, we talked about 1. If it is 2, output generated should be 2. So in Q2, we have looked for 0, 1, and 2. Then let's go for Q3. In Q3, if you get 0, if you get 1, or if you get 2, it signifies that we are doing our process again, the initial process. What if we get 1, go to Q1. If we get 0, go to Q4. If we get 2, go to Q5. So on the input of 1, look, is that 1 part of 1 to 0? So on the input of 1, we are going to Q1. On the input of 0, we are going to Q4. On the input of 2, we are going to Q5. So we checked for Q0, Q1, Q2, and Q3 for all the valid cases of input alphabet 0, 1, and 2. Okay, now let's go for the other cases. Let's say Q4. In Q4, if you get 0, what to do? 1, what to do? And 2, what to do? That we are going to check now. If we get 0 here, continue with 0, generating output as a 0. If we get 1, that 1 would be the part of search which we are looking for. That is 1, 2, 0. So go to Q1. If we get 2, what does it signify? You should go to a place from where we are generating output as a 2. So in case of 2, we are going to Q5 because Q5 we used for generating output as a 2. Now in Q5, if we get 0, go to this. If we get 1, we get 1. Search for 1 followed by 2 followed by 0. If we get 2, so this is a Moore machine to change each occurrence of a substring 1 to 0 into 1 to 1.